Hello, Mr. Ahmed here. First video for intermediate algebra. Our goal is to work with the parts of a quadratic function. These notes can be printed off via your PowerSchool learning page if you would like. Otherwise, you can follow along and use your device to fill in these notes, whatever works out best for you. I understand not everyone has access to a printer. And the filled in notes are also available on PowerSchool Learning as well. Use this with your first assignment in Big Ideas. And this note will correlate right along with that very first assignment that you're going to be working on through the textbook. So without further ado, we're going to get started. The quadratic function is not linear. So it is a nonlinear function. That comes in the form ax squared plus bx plus c. So when we take a look at this, we have an x squared term, we might have an x term, and we could also have a constant. No matter what, the constant thing that we're going to always see in a quadratic function is an x squared. The characteristics of the graph, we call it a parabola. It looks like a U. And it can either open upwards, and it keeps going up on and on forever, up to infinity. So the range, if it's opening upward, would be all reals based off of a minimum value. And if it opens downward, it also keeps on going downward forever and ever. And it would be all the numbers less than a specific value. Kind of misstated the first one when we said all reals. It's all the real numbers bigger than the minimum. The axis of symmetry is a vertical line. That divides the parabola into two symmetric parts. So essentially it's cutting it in half. So I'm going to pencil in our line of symmetry. Our line of symmetry is the line that we could draw up or down. And if we were to fold the graph over that line, it would land right on top of it, on both the left side and the right side. The vertex is the lowest or the highest point. So in this case, our vertex is the lowest point of the graph. Because it's opening up. It keeps on going forever and ever and ever in the upward direction. I should also label this as the axis of symmetry. Okay. The minimum or the maximum value. Each parabola could either have a minimum or a maximum. And we're going to identify those based off of the vertex. So the minimum or the maximum is always going to be the vertex of the graph. And it's either a max or a min. We're going to abbreviate those. And the y-intercept is the place where the graph crosses the y-axis. That's not overly imperative for our parabolas, but it is just one of those features that's kind of nice to know. One more piece with the axis of symmetry. Since it's a vertical line, we could always write the equation of it. In this case, vertical lines come in the form x equals, because it's the value of x, and x is equal to -3. Okay, so that's kind of the basics of the parabola. So when we go into our example problems here, we're going to first identify the axis of symmetry. the vertex, the y-intercept, and the maximum or the minimum value. So, first one says, first identify the axis of symmetry. So I want to locate, well, where could I fold it in half? I can see that this right here is the highest point of the graph, so that's actually a maximum, and my axis of symmetry is always right on that vertex, the vertical line. In this case, our vertical line's at -1, so the axis of symmetry is x equals -1. The vertex, that's that highest point, over 1 up 4, our vertex. X value first, y value second. The y-intercept is the spot where it crosses the y-axis. So I have to look at my y-axis, that's the one going up and down, and see where the graph touches it. Boom, right there. So we got to label that point for our y-intercept, which is 0, 3. And then finally, our maximum or our minimum value is right on our vertex. And for these problems, we're just going to give the y value for that. And in this case, our vertex, the parabola is opening downward, so we have a maximum. The maximum y value of this graph is 4, because it's up at 4. And that's our first example. Second one, axis of symmetry. Again, locate the vertex. Oh, what's going on here? It's not right on a point. But, funny business, it's going over by 2. So halfway over our axis of symmetry, since it's going by 2's, we are going to state when I draw my vertical line that x is equal to 1. Notice we abbreviated axis of symmetry A of S. And that's what that's standing for. A of S is axis of symmetry. I should actually write that down. The vertex. Let's see where our point is. It's a low over 1, down 8, in between 8 and 10 is 9. So our vertex is 1, -9, because we were down. Y-intercept, place where it crosses the y-axis. Well, I gotta look. Right here is where it's crossing the y-axis, so that would be at the point 0, -8. And now determining maximum or min. It's going up forever and ever and ever, so I can't have a max, so we have a minimum value. The minimum, we've already stated it, it's part of the vertex. The minimum y value was -9. So, there's 2 for you to try on the back. I am going to leave those for you to try. The answers for those 2 questions are indeed posted on the PowerSchool Learning page. They're the same exact things as what we just did for these 2 problems. If you would like to repeat these 2 examples, just rewind the video, take a look at those, and then proceed over to your big ideas for your assignment. Have a great rest of the day.